Hi, my name is Tyrone Baird, and today I'll be discussing mutual inductance using LVDTs. Mutual inductance occurs when one coil is energized by an input voltage. Current begins to flow in this coil, and a magnetic field also gets generated. If a second coil is placed in close proximity, the magnetic field will link itself to the second coil, and if a change is produced in this magnetic field, then a measurable EMF is produced in the second coil. This is also described mathematically by Faraday's law. LVDTs make use of this principle. They can be used to measure displacement by measuring the EMF that's generated from the change in flux linkage from the first coil to the second coils. The schematic here shows what an LVDT looks like. It consists of a main coil and two secondary coils which produce the output. The main coil takes in the input, and the movable core in the middle is used to stimulate the magnetic flux field lines to generate the EMF. And this can be seen in the experiment. Okay, so here we have our basic setup for the LVDT. Here in the middle, you can see this is the actual LVDT itself. It consists of two outer coils and one center coil. The center coil is the main coil that takes in the input voltage, and the two adjacent coils is where we take our measurement from. The center coil has 75 turns, and each adjacent coil has 70 turns, separated by about 3/8 of an inch here in between. And the center coil is collected via these alligator clips to this 120 volt to 12.6 volts AC step-down transformer. So it takes our 120 volts AC input from the wall and just steps it down to a manageable 12.6. And then over here we have a 10 ohm, 10 watt resistor to help us dissipate some of that heat that gets generated when the current flows through this coil. Because we don't want the coil to get too warm, then we'll lose continuity. So, and then also here we have our alligator clips connecting our output coils to our fluke multimeter, which will show us our voltage in millivolts and the change of voltage. And then over here, we have this wooden rod that's connected to a ferrite screw that will act as our core. And we'll just slide this in, and it has some tick marks in here to tell us position-wise where the ferrite screw is located within the LVDT. Okay, so right now there's nothing going on, it's powered off, so I'm going to turn it on, and you can see there's going to be a little bit of voltage because of that current that's flowing through the coils. Okay, so you can see about 2 millivolts, and it just settles about that range there. So first thing I'm going to do is I'm going to slide in the core, and you'll notice the difference in the change in voltages. Okay, that's relatively close to the center position right now where the ferrite core is located. So it's right now hovering about 6 millivolts. And now if we we disrupt the magnetic flux lines that are linking the center coil with the outer coils, we're going to notice a difference in the millivolts that gets generated. So I'll do that now. So you can see there's an increase there. I move it about a half an inch out, and you can see about a 7.6, from 6 to 7.6. And if I move it about an inch out, you can see there it goes up to about 9.6, and that's because we're linking more of these coils with these coils, so we're getting a larger EMF being produced in the outer coils. So if I keep moving this out, you're going to see a point where it starts decreasing, and that's because we're linking less coils because the ferrite core is closer to the outer coil, so it's not linking as many between the center and the outer. And if I move this back in, you'll see the increase once again and then the decrease. So these tick marks can tell us relatively our position within the core, within the LVDT, the coil itself, and then that's what we can use to measure displacement based on voltage just being applied. So that's the basic principle behind the LVDTs. It's just a good tool to measure displacement based on voltage that's being applied. And it uses Faraday's law of induction that talks about linking two coils together via voltage and EMF generated.